All right, more graphing with sine and cosine. So, again, I'm just going to work my transformations left to right. The 1/2 out front is a vertical shrink by 1/2, and that's going to give me an amplitude of 1/2. So this little curve is going to be really tight around the x-axis, or tight around my midline, I guess. This is a sine curve. So my sine curve is a wave, but it's a sine curve. I have a negative there in front of my x, so it's a sine curve with a reflection over the y-axis. So remember, for sine, reflections over x and reflections over y are the same. They make the same picture. It's just going to make my wave go down before it goes up. So I'm not going to graph the normal sine curve. I'm going to go down and then up. All right. Keep going here. I also have the 2 in front of my x, and that affects the period of the function. We do 2 pi divided by our number in front of x to give us the period of the function. So the period of this function is pi. So from my start to the end of one period is going to be pi units. And if it helps you to like kind of build your little sketch off to the side, I think that's really helpful for me. All right, so we're working left to right. We've done all of that. Now we need our phase shift. So if we look at our phase shift, we always do C over B. Get a different color here. C here is 2 pi, and B is -2. So even though we dealt with that negative and the 2 separately when we were looking at transformations for the period and for the reflection, which was y-axis, it's gonna affect our phase shift together. So our phase shift is C over B. C is 2 pi, and B is -2. So 2 pi divided by -2 is going to give us a negative pi. So that's going to be pi to the right. Remember, when we get negatives there, when we're working with transformations left and right, that's a phase shift to the right. The other way, it's kind of easy to think about this one in terms of factoring. You have -2x plus 2 pi. To think about that one in terms of factoring, you would factor out the -2 and end up with x minus pi. So you can think about that either way. All right, the last thing is our vertical displacement. Our vertical displacement here, we have a +3, so it's going to be up 3. I'm going to go ahead and dot in that line because that's going to move our whole function up. So this is going to be the new midline of our function. My start is going to be pi to the right. So here's pi. I'm starting on my midline because I'm graphing sine. So I'm going to I've done up 3. I started pi to the right. The period of my function is pi. So from pi to 2 pi. So there's the end. Start and end of one period. For sine, halfway in between is where I cross that midline. So I've kind of dealt with the period there. The reflection over the y-axis means I'm going to go down and then up. And I'm only going down 1/2 to deal with that amplitude of 1/2. So again, we talked about how this one was going to be really tight around that midline. So I started over pi. My amplitude is 1/2. The period of my function is pi. And that's what one period of that guy looks like. And you can keep on graphing that out. If you want to see the whole thing graphed out, you can pull up my key on Canvas. Domain here is -infinity to infinity. We have no domain restrictions. Range here, be careful. The bottom of our function starts at 2.5, and the top of our function is at 3.5. We are including those endpoints. I understand that on a graph like this, if I were to give you one like this on the test, that you would need to do some approximating when you're graphing, and that's fine. So just do the best you can.